Hello, Math 45 students. We are going to pick up lecture on page 15, section 7.6, which is about solving systems with Gaussian elimination. So what we want to do is we want to see these systems of equations turn into an augmented matrix. So what you can see here is that this first equation is written as this first row. And we have our second equation here is written as our second row. We also know that that first column represents the x and the second column represents the y. So notice how I have 3x. I have a 4x. I also have a 4y and a negative 2y. And this is what each one of them is equal to. So here I have and you always go row by column. So I have 2 rows by 3 columns. So this is a 2 by 3 matrix. Down below, same thing, right? We have 3 equations. So notice here for our second equation, I have a 0. Well, notice how I have an x, a y, and a z column. This equation is missing a z value. Since it's missing a z value, we put a 0 there as a placeholder, okay? So that's going to be really important. And of course, since this is a row by columns, we have a 3 rows, and we have 4 columns. So this is a 3 by 4 matrix. So here it says, hey, write the augmented matrix for the given systems of equations. So I know I'm going to write this as a matrix. It looks like I have 1, 2, 3, and I have 3 variables plus what it's equal to. So this is going to be a 3 by 4 matrix. So the first thing I'm going to do is write that first row. So that first row, I'm going to write the coefficients. The coefficients is a 1x, that's a 1 there, a 2y, and a negative 1z. And I can put a line there, sure, and that's equal to a 3. So now, if I do my second equation, I have a 2x, a negative 1y, a 2z equal to a 6. And that third row, I have a 1x, a negative 3y, a 3z, and it's equal to a 4. So that would be my augmented matrix. Now, we're going to do the opposite. Now we're going to start with the matrix and write the equation. So remember, we always go alphabetically, so this is an x, a y, and a z, and what it's equal to. So for that first equation, I have a 1x, a negative 3y, a negative 5z is equal to a negative 2. For that second equation, I have a 2x, a negative 5y, a negative 4z is equal to a positive 5. And for that last row, I have my equation number 3, negative 3x plus a 5y plus a 4z equal to a positive 6. So that would be my system of equations. So notice I can go from a system of equations into a matrix, or from a matrix into a system of equations. So you can go back and forth between these two notations. So here it says solve the system using Gaussian elimination. Now it says Gaussian elimination, but I don't actually want to do Gaussian elimination. Instead, I want to use the matrix in the calculator. So the first thing we want to do is we want to translate this into a matrix. So remember that first row, this first row, I'm going to go ahead and write those coefficients. So I have a 2x, a 3y, and I have it equal to a positive 6. And that second row over here, I have a 1x, a negative 1y, and the fraction 1/2, hopefully everybody knows that's the same as a 0.5. I think it's just easier to use it as a decimal, so I'm going to say a 0.5. Now, I'm going to go into my TI-84 plus CE calculator to do the rest. So I'm going to go ahead and pause this so I can bring it up. So now I have brought up my TI-84 plus CE calculator to help me out. So what I want to do is I want to go ahead and write this as a matrix. So I'm going to go ahead and put in my matrix. So I'm going to go to second, and then the matrix is right here with that x negative 1. So second, notice how that button turned red, and then the matrix, okay? So then I want to go over to edit, and I want to edit my matrix A. So I'm going to press enter. From here, I know this is 2 rows, so I'm going to go a 2, and I have 3 columns, so it's a 2 by 3. Now, I'm going to copy down my entries from the matrix. I have a 2, a 3, and a 6. And in that last row, I have a 1, a negative 1, and a 0.5. So now I have my matrix. So now what I want to do is I want to figure out what this is going to equal to. So I'm going to clear my screen by going to second quit. So second, and then the button right next to it, which is mode. See how it's blue? So I'm going to go to second, quit. And I think I pressed something wrong, but clear also kind of helps as well. So now that I'm here, I want to do the actual math. So I'm going to go to RREF. So I'm going to go to second, matrix. I'm going to go down to math, and what I'm doing with the matrix is I'm going to do the RREF. So I'm going to press enter, and I'm going to now input the matrix A because that's what I called this matrix, matrix A. So now I have to call it. So I'm going to go to second, matrix. See how it's already on A, so I'm going to press enter, and now I have the matrix A in here. So now when I press enter, it has my matrix. So I'm going to go ahead and copy that down. So I went ahead and copied down the matrix, and notice how that RREF A, and then I have that 1, 0, 1.5, and 0, 1, 1. So I just copied down my calculator screen onto my notes. So now what does this actually tell us? Well, it tells us that this first row, I have some solutions. Remember, I have x, y, and what it's equal to. So when I rewrite it as a system of equations, that first yellow highlighted row tells me it's 1x plus 0y is equal to 1.5, which is the same as saying that x is equal to a 1.5. So perfect, I know exactly what my x is equal to. Now, the second row is going to tell me some other information. Well, I have a 0x plus a 1y is equal to a 1. So really, this is saying that y is equal to 1, which is perfect. So now, my solution, you always try to write it as an ordered pair. So remember, you want to go alphabetically, so it has my x and my y. So it looks like I have a 1.5 for my x value, and my y value is a 1. So 1.5 comma 1 is going to be a solution to the system of equations. Okay. And here it kind of explains how to do it. Instead of teaching you Gaussian elimination, I'll taught you how to do Gaussian elimination with the calculator. Okay. So again, for this one, we are going to do our matrix, okay? So we are putting this into the matrix, and we're going to be using the RREF from our calculator. So I'm going to put this into the matrix. So I have a 2x, a 1y is equal to 1. From that second row, I have a 4x, a 2y is equal to a 6. So when I put this into my calculator, I'm going to clear this, and I'm going to go to my second matrix, and I'm going to edit. It's still a 2 by 3, so that's fine. And now I have a 2, a 1, and a 1. And then I have a 4, a 2, and a 6. So now I have this matrix as is, perfect. So now I'm going to second, quit. Now I'm going to tell my calculator to do the RREF. Basically, it's going to be solving the solution for me, right? It's telling me to use this matrix and do the Gaussian elimination using my graphing calculator because technology is wonderful, right? So now I'm going to go to my second matrix. I'm going to go to math. I'm going to go down to my RREF. Enter. And I'm going to call that matrix A. So second matrix A. Now that it's there, I'm going to press my enter. So now I have solved it just by using my calculator. So again, at this step, I'm just going to pause it so that way I can have time to go ahead and copy what I see on my screen onto my notes. So now I have copied down that screen. So I have that first row as 1.50 and then that second row 001. So let's see what this is actually telling me. Let's look at this bottom row. Remember, I have the x, the y, and what it's equal to. So that second equation, I have 0x plus 0y is equal to 1. This is saying that 0 is equal to 1. Well, is having $0 the same as having $1? No, it's not. So here, I'm going to have a no solution. That is not possible, okay? So just know that whenever 0 is equal to, or actually whenever two numbers that aren't equal, like 0 and 1 or like 2 and 5, and there's an equal sign between them and they're different, it's going to be a no solution. It's not possible. Okay, so now let's see what happens in this one. So again, we're using our TI-84 calculator. We're going to write this into a matrix. So I have a 3x, a 4y is equal to a 12, and a 6x and 8y is equal to a 24. So on my calculator, I am going to clear my screen. I'm going to enter into my matrix because I'm going to edit my matrix A. It's still a 2x3 system, so that's perfect. I have a 3, a 4, and a 12, a 6, an 8, and a 24. So now that I have that, I'm going to clear my screen, and now I'm going to do the RREF. So second matrix, go to math, go down to your RREF. You're going to call your matrix A, and let's see what that gives you. Okay, so I'm going to go ahead and copy this down. So I have copied down my matrix from my calculator onto my notes, and I see something else that's kind of weird, that's going on. Look at that last row. If I'm looking at this second row down here, well, this is saying that 0x plus 0y is equal to 0. So essentially, it's 0 is equal to 0. So you have to ask yourself, is 0 the same value as 0? Is the left-hand side actually equal to the right-hand side of the equal sign? It is. So because 0 is always equal to 0, you're going to have an infinite amount of solutions. So because 0 is equal to 0, because that is a true statement, it's infinite. Versus in the previous problem, we had 0 is equal to 1. That was false statement. That is not, the right-hand side did not equal the left-hand side, so that was a no solution. So please be aware of the two differences between infinite solutions and no solutions, okay? It all depends on whether the left-hand side of the equal sign is equal to the right-hand side of the equal sign. Okay, so here what we are going to have 3 rows, and it's going to be by 4 columns. So I definitely want to write this in the correct matrix. So it looks like, I'm going to need myself more room. So it looks like from that first row, I'm going to have a 1, negative 1, 1, positive 8. From that second row, I'm going to have a 2, 3, negative 1, negative 2. And from that last row, I have a 3, negative 2, negative 9, positive 9. So that I have my x, my y, and my z. So I'm going to go ahead and remember that this is a 3 by 4 matrix. And I remember that I'm going to do my ref into my matrix A, and it's going to give me back some information. So I'm going to go ahead and put this into my calculator. So I'm going to clear my screen, second matrix, go down to edit. I know now that I have a 3 by 4. So I have 1, negative 1, 1, and 8. Then I have a 2, 3, negative 1, and a negative 2. And I also have a 3, negative 2, negative 9, and a positive 9. So I'm going to second quit, and I'm going to go to my second matrix, go to math, go down to your ref. Oops, that's what happens when you go too fast. So let's go a little bit slower. Second matrix, go to math, go down to ref, press enter. Then I'm going to second matrix, and I want that matrix A, so I press enter. And there's my matrix. So I'm going to go ahead and copy this down onto my notes. So it looks like I copied my screen from my calculator onto my notes correctly. I have that first row, that second row, and that third row. So I don't know, you can either start from the top row or the bottom row. If you want to start at that bottom row, then this is going to be my equation number 3. It's saying that 0x plus 0y plus 1z is equal to 1. So it's really just saying z is equal to 1. Perfect. Now for that second equation, equation number 2, I have 0x plus 1y plus 0z is equal to a negative 3, which is the same as saying that y is equal to a negative 3. And then that first row, is really saying 1x plus 0y plus 0z is equal to a 4. So that x is really equal to a 4. So because this is a triple ordered pair, my solution, I'm going to have my x value, which is a 4. I'm going to have my y value, which is negative 3, and my z value, which is a positive 1. So my solution is 4, negative 3, positive 1. Well, I hope that makes sense in translating. And for this example, what we are doing is we want to make sure that we're not tripped off by having any missed variables, right? So that first row should be, really repetitive at this point. So I have a negative 1x, a negative 2y, 1z is equal to a negative 1. Now for that second equation, we want to be a little bit careful. So I'm going to just write it up on top to remind myself I have my x, my y, and my z, and what it's equal to. So I have a 2x, I have a 3y, but what about my z? Well, remember here your z value is missing, so as a placeholder you need a 0. And then I have it's equal to a 2. And that last row, well, the x value is missing, so I need a placeholder as a 0. My y value is 1, and my z value is a negative 2, and it's equal to a 0. So now I'm going to plug this into my calculator, and here I definitely still have a 3 by 4 matrix. And I know eventually I want to do the ref once I plug that into my calculator correctly. Oh, that would not give me enough space. Hold on. Okay, so now I'm going to clear my screen and go to my second matrix. I'm going to go to edit. I'm going to edit that 3 by 4. And I have a -1. I have a -2. I have a +1. And I have a -1. I also have a +2, a +3, a 0, and a +2. And I have a 0, a 1, a -2 equal to 0. Perfect. So now I'm going to second quit. I'm going to go to my second matrix, go to my math, go down to your RF. Oops. There we go. And I have to call that matrix A. And then I'm going to press enter. And this is what I get. So I'm going to go ahead and copy that down as well. So I think I've written down the calculator matrix onto my notes. So I have that 1, 0, 3, 1, that 0, 1, -2, 0, and then that last row is all zeros. So the fact that that last row is all zeros, that should be a clue to you that something kind of weird, this is a special case, right? Something should be jumping out at you. So let's think about that for a minute. Let's look at this last row. Remember, I have my x, my y, my z, and what it's equal to. So this is really saying that I have 0x plus 0y plus 0z is equal to 0. So all of those are zeros equal to 0. So this is a true statement. What do we say when we have a true statement? When the left-hand side is equal to the right-hand side. Hopefully you guys remember, this is going to be infinite solutions. So infinite solutions should be your final answer here. And it looks like that is the end of this chapter. So if you guys have any questions, please feel free to email me or the Math Success Center or the tutor for more help. Thank you.